Alright, in this video I'm going to go over worksheet number 7. So here question number 1 is asking which one of the following is most likely to be an ionic compound. So we are looking for which one has the electronegativity difference is more than 2, right? So we have the periodic table with the electronegativity values. So the value for calcium, I'll just look it up, is 1.0, and then chlorine is 3, okay, 3.0. So for B, I got carbon is 2.5 and oxygen is 3.5, carbon is 2.5 and sulfur is 2.5 and sulfur is 2.5, oxygen is 3.5, oxygen is 3.5, and fluorine is 4. So we are looking for two elements where electronegativity values are more than 2, right? Difference is more than 2. So here I get 3, this is 1, 3. So 3 minus 3.0 minus 1.0 is going to be 2. So this is 2 or more. So that's the only one I have here. The difference can be more than 2, right? 2 or more. So answer is going to be A. 2. Which of the following pairs element will be most likely to form an ionic compound? The same question, same kind of question here. We are looking for an element, two elements where the difference is going to be more than 2. So the chlorine value, electronegativity value is 3.0, iodine is 2.5. So the difference cannot be 2 or more. So aluminum here is 1.5, and potassium is 0.8. Difference cannot be 2. So chlorine here is 3, and magnesium here is 1.2. Difference is 1.8. Carbon here is 3. Carbon is 2.5. Sulfur is 2.5. And E here, aluminum is 1.5, and magnesium is 1.2. Alright, so here in this question, which of the following pairs elements will be the most likely to form an ionic compound? Difference is 0.5, difference is 0.7, difference is 1.8, difference is 0, difference is 0.3. So which one is going to be the answer? Well, here on the chlorine, let me see one more time, magnesium is 1.2. Alright, so difference is 1.8, right? Okay, so here's saying that this will be most likely to form an ionic compound. So this is going to be the most likely, right? So this is the one closest to 2. So here's the point. So this number 2 here is human-made number. So we just say if it's more than 2, it's going to be, we call it ionic. If it's less than 2, we're going to call it polar covalent. So this is the a number we made it up. So 1.8 is pretty close to that number. So we can say that this is the one most likely going to be. Okay? But, I mean, this is not ionic. We don't want to call this ionic. This is just most likely to be ionic. Which one of the following is most likely to be covalent compound? The same similar question problem here. Potassium is 0.8, fluorine is 4, difference is 2.2, right? That's definitely ionic. Calcium here is 1, and chlorine is 3. So definitely there's going to be, difference is going to be 2, difference is 2. Actually 2.2, so this is ionic. Sulfur is 2.5 and fluorine is 4. Difference is 1.5. All right, here aluminum is, the value for aluminum is 1.5 and oxygen is 3.0. The difference is 1.5. Aluminum is 1.5, oxygen is, 3.5, difference is 2. And then we don't want to worry about this polyatomic ions this time, so don't worry about that. I'll just erase this one, okay? That's not the answer. Obviously here, the one is not 2 is going to be here C, right? Alright, so question number 4, it's asking you to write the blue dot symbol. So what you do is you're going to write the electron configuration and you're going to work on the PB, right? I'm just going to skip this question. So I'll use that symbol for the chlorine atom, chloride ion. So we have a chloride ion here. We want to know how many electrons we have. So we have 17 electrons for a regular chlorine, but now we have a chloride, so we have 18 electrons, right? So let's write down the electron configuration. 1s2, 2s2, 2p6, 3s2, 3p5. All right, so here we got 17, but I have 18 electrons. Is going to be 3p6. That's going to be the loose dot. So that's going to be the electron configuration. And then I have here 8 electrons. So chlorine negative 1, 2, 3, 4, 5, 6, 7, 8 electrons in total. I don't want to work on lead because it has 82 electrons. It's going to be long, so you can work by yourself. It's going to be a homework for you. All right, so question number 6 asking which elements listed below has the greatest electronegativity. You're going to look it up from the periodic table. You'll see that it's going to be B here. Which of the elements listed below is the least electronegative? You're going to look it up the table again. You're going to get this strontium with the answer. Question number 8, a polar covalent bond would form in which one of the following pairs of atoms? Well, we are looking for a covalent bond, and then we are looking for a polar covalent one, right? So what would be the answer? So you have chlorine and chlorine here, silicon and silicon, calcium chloride, chromium and bromine, and then phosphorus and chloride. So we are looking for here which one is going to be the polar covalent. So here the difference is 0. Here's a 0. This is an ionic compound, right? The difference is going to be more than 2. This is ionic. This is nonpolar, so it's going to be pure covalent. This is pure covalent. All right, and then here, this is going to be chromium is 1.6, bromine is 2.8. Difference is it's going to be 1.6, right? Actually, it's going to be 1.2. All right, and then phosphorus here is 2.1, and chlorine is 3.0. Difference is 0.9, difference 1.2, 0, 0. This is ionic. So I think there's a typo here in this question. So these are going to be the 2 right answers. This is right and this is right as well. Okay. Which one of the following, these polar covalent bonds will have the greatest percent ionic character? The percent ionic character is higher the difference of the electronegativity values is going to be higher the ionic character. When we have more than 2 value difference, then we're going to call it the ionic. But if you have less, so more the difference is going to be the more ionic character in overall. All right. So which one is going to be the highest ionic character? The one has the highest difference. So here's this case is going to be hydrogen and fluorine. All right, so question number 10, a non-polar covalent bond will form in which one of the following pairs of atoms? So we are looking for which one is going to form a non-polar molecule. Well, the one is not difference is going to be 0, 1 is going to be the non-polar. So we got bromine, and bromine is 2.8, 2.8, difference is going to be 0. Okay, so these are not going to be 0. I'm just going over fast because they're all the same kind of questions, right? Once you know the table, you can plug the numbers in. If it's more than 2, it's going to be ionic. If it's less than 2, it's going to be polar covalent. If it's like 0 or closer, it's going to be a non-polar. All right. All right, in this question 12, we're going to work on nitrogen molecule. So this is drawing structures of molecules. So we got into here, right? Into nitrogen molecule, and we are gonna find out how many valence electrons we have on nitrogen. So nitrogen has 1s2, has 7, right? 1s2, 2s2, and 2p5. So it has nitrogen 1s2, 2s2, and then okay, so this is going to be 3. Okay, so we have here 5 valence electrons. All right, so we have 5 valence electrons in each nitrogen. So nitrogen has 5 valence, so 5 times 2 is going to be 10 electrons in total. We can use up to make our molecule. So nitrogen and nitrogen, we're going to write 2 nitrogens, and we're going to form a single bond in between. All right, and here we have only 8 electrons left. So I'm going to make octet 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, so now I run out all my electrons, right? I don't have any more electrons, and these atoms are not octet now. Well, what we're going to do is now we're going to move electrons to make more bonds. So I'm going to have here this 2 electrons going to move here. So I have nitrogen 1, 2, 3, 4, double bond, and nitrogen 1, 2. So now still this electron on the atom on the right is not octet. So I got 2, 4, 6 electrons, not 8. So this is still not an octet. So we're going to make this octet. Well, how we do it? We're going to move another pair. All right, let me draw a pen. Just a second, what happened? All right, so we're going to move this one down here. All right, we're going to move this one down here. So we are going to get nitrogen, triple bonds, nitrogen. So we have 2 pairs here, and then we got one, I mean 1 pair here and 1 pair here. So that's going to be a loose structure. So let me color it right here, and N, 1, 2, 3, lone pair, lone pair. So number of lone pair electrons, 4, right? We got 2 pairs of electrons. It's going to be total 4. The total number of bonding electrons in the molecule formaldehyde. So we have a carbon, and we have oxygen, and then we have hydrogen, and we have hydrogen. So you can find out more kind of orientations in the lecture slides. So I'm going to go with the way it is. So here I have 1 valence for every hydrogen, so I'll make twice the number. Plus I have 4 valence for carbon, and then I have 6 valence for oxygen, so a total of 12 electrons. I have 12 electrons to use to construct my molecule. First I make a single bond, and then I'm going to make octets. So hydrogen does not need an octet, we just do for oxygen. So I have 2 electrons in here, 2 here, and 2 here, total of 6, and I have only 6 left. 1, 2, 3, 4, 5, 6. So here oxygen is octet, that's good to go. Hydrogens are good to go, but not carbon, right? Carbon is not octet. So what we're going to do, we're going to move electrons to down here to make octet. So once we do that, carbon will have a double bond with oxygen, and then we'll have a hydrogen here, and have a hydrogen here. Now this carbon is octet because 1, 2, 3, 4 pairs of electrons around it is an octet. All right, that's going to be the structure. All right, question number 14. As usual, we are counting number of valence electrons, and then for carbon we got 4. For sulfur we got 6 in each, so 2 times 6. So 4 plus 2 times 6 is going to be 16 electrons. So we have 16 electrons to construct our molecule. I'm going to put the carbon in the middle, and I'm going to have sulfur on the left and sulfur on the right. And I'm going to use those 16 electrons to construct my molecule. So I'm going to make a single bond in between. So I used up 4 of them already. So 1, 2, 3, 4, 5, 6 is gone. So I have only 6 left. 1, 2, 3, 4, 5, 6. So I run out all my electrons. Alright, so we are good with sulfurs because they are all octet, but not the carbon in the middle. Carbon is not octet. So what we are going to do now to make an octet for carbon, we're going to move electrons to the right here. So I'm going to have sulfur double bond with sulfur having 4 lone pairs. Carbon, sulfur, 1, 2, 3, 4, 5, 6. Now this is still not enough because carbon here is not octet yet, right? It's not octet. So what we're going to do, we're going to move these pairs this time. And now we're going to have sulfur double bond, sulfur, carbon and sulfur. So here we got lone pairs, and then carbon having 4 bonds around it. So it's going to be 8 in total electrons. It's an octet. So this is octet, this is octet, and this is octet. They're all good to go. That's going to be the structure. So I was about to run out of my time, so I just can record only 15 minutes. So I'm going to stop here, and then you can work on question number 16 by yourself. If you have any questions, just let me know. All right. Take care.